Welcome, welcome. It is day 8 of Advent of Code, and we have about 15 seconds left. Now, I want to change my paradigm a tiny bit. I hope that's the right word. Um, in that, I am not going to stress about the speed as much, and I'm going to focus more already on explaining what I'm thinking as I'm going. But as I'm saying it, the clock literally went down and it went to 8, and I'm going to start my challenge. I'm gonna start reading all of it, and it's actually not that much, which is very pleasant. Day 8, Haunted Wasteland. You're still riding a camel across a desert island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. Okay, she just vanished. To be fair, she just finished warning you about ghosts a few minutes ago. Oh, that's helpful to know. One of the camel's pouches is labeled maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. I'm wondering, like, we are going through the desert, and the whole point is that um, we're trying to find where the snow went in the desert. Well, let's keep going. At least you're pretty sure that's what they are. One of the documents contains a list of left right instructions, and the rest of the document seems to describe some kind of network of labeled nodes. It seems like you're meant to use the left right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the map, what is about that? What about that elf? What happened to her? We just leaving her? After examining the maps for a bit, two notes stick out: AAA and ZZZ. You feel like AAA is we are now, and you have to follow the left right instructions until you reach ZZZ. Or some people might say ZZZ. Um, I love how these puzzles are always this guesswork. You examine two notes stick out, you feel like, right? Okay, and it seems like those are always like, hey, just go for it. And then the second part is like, no, that's what it actually is. And it's like it's just funny. This format defines each node of the networks individually. For example, RL. Oh, okay. So if I understand, we have one node and a lot of instructions, I think. Okay. RL is an example. Starting from AA, the following left right instructions, how many steps are required to reach ZZZ? Okay. Starting with AAA, you need to look up the next element based on the next left right instruction. Oh, okay. Okay. RL, left right. This is LLR. Okay. Based on the next left right instructions in your input. In the example, starting with AAA and go right by choosing the right element of AAA, which is ZZZ, CCC, sorry. Okay, then L means to choose the left element of CCC, which is ZZZ. By following the left right instruction, you reach CCC, or Z, yeah, ZZZ in 2 steps. Of course. See, what are you doing with pronouncing these labels like this? Don't do this to a German like me. Of course, you might not find ZZZ right away. If you run out of left right instructions, repeat the whole sequence of instructions as necessary. RL really means RL, 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 and so on. For example, here is a situation that takes 6 steps to reach ZZZ. Okay, so I have two examples really, and I'm going for this one because of the repeat. And day 8 downloaded already. Okay, so I'm gonna do my prep work really quickly. Boom, and I know it takes 6. So my first thought is this doesn't seem too difficult. So I want left and right, left and right, left and right, left and right. And it's just looking up. Now let's see. Yeah, right now it just seems like we keep going. We could keep going step by step, and like we find one, and then we get the next one. I don't see an optimization yet, in the sense that hey, we can like shorten the path or try. Something like this is useless. I see something like this, and I see something like this, and there I see ways to do shortenings. Okay, there is a few of these happening. Um, actually, that might be actually very interesting to see. Yes, that's I missed it. The DRR. Aha. I have the feeling that it's gonna take forever. Maybe not step one, but there's some type of twist where it's gonna take forever. I'm gonna go for the line by line approach. Okay. And as I do, I will see, like we should see, boom, all of the input. Perfect. Okay, so oh yeah, now we're getting it twice as well. Is there a better way to do this now? Now that oh, I don't like this. Now that I'm okay, I still need to work on my template because now I'm getting everything twice, which is a little bit annoying. I'm not gonna lie. Yeah, I'm gonna change my um test it a little bit more my example just so that it just works a little bit better of what I needed to do, but that's okay. So LRR. So we go line by line. The first line is helpful because that's the instructions. So I'm already gonna say instructions is LL0, and then I want to start with the third line. I don't care about the rest. So I'm gonna do this, and I am getting now the right stuff. Now I have the index and I have a left and a right. So I really just want to split the input by this. I'm very sorry for the background. There's a dog outside that's just barking. What if it lost the owner or something? I hope not. Or maybe the owner is going walking with him. So we have AAA, and then we have like the two coordinates. Now I can, in our instructions, I can actually replace L with 0 and R with 1. And I might actually do that. Is there such a thing as replace? I don't know the right instruction, but I can say map or x for x in this. That's, well, I'm getting the characters now. So let's say C. So C for C in, oh, this is how I can do this. If part 2 equals, if part equals 0, then return 0. This is how I can make sure that I actually don't, I'm still figuring all of this out. This is how I can make sure that I can keep this without being bothered by part 2. Perfect. I also want to check my print instructions. So right now I'm doing getting the L and R individually characters, but now I want to say 0 if C equals L, else 1. Perfect. That is exactly what I want. That's exactly, now I'm getting zeros and ones for lefts and rights. In that way I can really easily address the right one of the tuple that we already have here, which is amazing. Now it's not going to recognize this as a tuple like this, which is sad. Instructions, then we have directions, which is going to be a dictionary. And then we're going to say direction of, let's say, deers. And then deer equals this. And then I want to say deer 0 equals deer 1 dot split by the comma. Now I don't care about the brackets. I don't care about the bracket. Key arrow AAA. Deers, I have deers in my utilities function, so it's not happy about this. Rename the element. Directions. Direction. So what's going on right now? Not equal, comma. Yeah, equals, like this. Now, okay, so we are almost there. Now I just have the stupid brackets in there. And I want to see, can I remove unwanted characters? Wait. I'm already like forgetting half of my stuff. Can I strip this and this? Is that gonna cause, is that gonna do it? Oh. Okay, I see. Here, strip. Strip first, and then split it. Yes, that worked. So A is BB. Yes, okay. Now we have our directions. I only need this like this. Now we have all our directions, which is amazing. Okay. And now we go while. So current. Okay, so let me explain. I know I've kind of fumbled through this a tiny bit. I am going through my lines, and then I'm really quickly parsing my instructions. What am I doing? I'm going through the first line, and I say, like, I define it as each character. So I'm going through every single character called C. And I want to put 0 in the current position of our list if C equals L. Otherwise, I want to put 1 because R is the only other one that exists. So we're getting zeros and ones, which is perfect for addressing our directions dictionary. Our directions dictionary go through the rest of our input, and we split by the equal sign, because then we get on the left we get, hey, that is where we're at, and then on the right we get 2 possibilities of where we want to go. So we save in that directions, we save on the left, that's the address C, we save, hey, that is where we're at, and on the other side we save the 2 options. We first sanitize it with the brackets, and we split it by the comma. And then we have it all as a nice directory. Now what we want to do is we want to say, hey, currently we are at, and target is that. And I have a feeling the easiest way for them to change the complexity here is that they're gonna say AAA and ZZZ are gonna be different. And they actually choose 2 that are actually way harder to find, and it's gonna take way longer, and that's where we need to find optimizations. That's my guess for the second part. But for now, we are starting at AAA, need to get to ZZZ. So what are we gonna say? While current is not equal to target, we're gonna keep doing our loop. I also want to try to figure out steps is equals to 0. And then we want to return steps because we want to know how many steps it takes to get to where we are going. Now, every time we're doing a step, plus equals 1. Every time we do a step, what we really want to do is we want to go directions of current, and then we want to go through instruction, our current instruction. So we want to keep track of which one our current instruction is. And that's how I'm going to do it. Instruction 2 is just empty. This is what I'm going to do. I'm going to pop out from the front the current instructions that we have and feed it into 2. If the current instruction is empty, we swap them. That's what we're going to do. So I equals ins.pop 0. Now, optimization would be that this is not a list, but this is a DQ. So if we need to optimize, we're going to optimize to a DQ. So that's our current instruction, and this is what we need to address. That is going to be our new current. Okay, now current equals this. And that's it. It keeps doing that. Now it's going to check here, hey, have we actually done it? Then cool. Now I also want to make sure before we go to the while loop that we actually sort this out, this instruction. So if length of ins is equal to 0 because we have just emptied it, well, ins equals ins 2. I also want to say ins 2 dot append, because it's like a belt that's going in a circle, append I. Okay, so we are getting the data here and we're cleaning up the data here. And that should give us a correct solution and hopefully a correct answer. And we have a correct answer. Now, the sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. Let me just check something. I'm very sorry. You see, behind the scenes, you see me so many times. Okay, I just wanted to make sure that my fancy microphone, it's not that fancy, it's kind of old, that this is actually recording well. So I'm sorry for that. And I'm sorry that the light is not, the tree is not on. Usually the tree is on when I record. Sorry for that. Let's keep going. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps a bit longer. See, you should just do this straight away. Why are we not doing this in the beginning, just examining it a bit longer? Your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all the paths at the same time until they all simultaneously end up in node. What? What is that for logic? What? What? Okay, I need a drink. You see, I'm taking a tiny bit more chill than I have the last few days. I'm not rushing through this as much. Here's the 2 starting nodes. One A and 2 A. Because they both end with A. As you follow each left and right instruction, use that instruction to simultaneously navigate away from both nodes you're currently on. Repeat this process until all of the nodes you're currently on end with Z. If only some of the nodes you're on end with Z, they act like any other node and you continue as normal. In this example, you will proceed as follows. Step 0, you are at 1-1-A. All the paths go left and right. So actually our belt loop will stay the same. I just need to keep track of more things at the same time. Okay. It would still be after 6 steps. Okay. So we have a second example. Example 2. Not gonna lie, the simplest thing I have right now is just brute force. That's what's coming into my head right now. To get a solution for this. Is there... Oh. Here's the deal. A lot of the ghosts might get on similar paths as other ghosts. Let's say this. I'm gonna take my drawing tablet out for this again. Okay, so let's say we have this point, we have this point, we have this point. I'm just doing random coordinates, right? And we're going from here to here. Then we're going from here to here, going from here to here, going from here to here. Let's say we are a ghost. One of the ghosts starts right here. Okay. So one of the ghosts starts right here. And then one of the ghosts starts right here. We keep going. Eventually this ghost comes this path and then comes back down this path that we have already done. And I'm worried that if we have tons of ghosts going down the same paths, that there's some type of optimization that we can do in that way of memorization. Because this ghost now... Okay, that only happens though if they're in the same phase. So with our left-right instruction, the phase switches back and forth, left, right, okay? So every second one, it will be in the same phase. Now, if we have left, right, right, left, the phase change will only happen every 7. So that means the path is actually gonna go different. So this first ghost might go down here and then left. The second ghost might go down and then right. So optimization is actually really hard. I'm going to go with brute force for now and see if that's enough for Advent of Code. But actually thinking of how to cache long paths is an interesting thought, especially if we have so many ghosts. So, so all the ghosts start at all the locations that have an A at the end. So let's just store ghost current is all of these. And while I save all the directions, I want to here specifically pay attention to this. If direction 0, and then the third instruction, because they're always 3 letters, yeah. If the third one equals to A, sorry, my international keyboard, then I want to add it to ghost current. Append direction 0. Let's just see right now. Print what our ghost current is. What happened now? What just happened? Ah. This only works for part 1. if part equals 1, because our inputs are apparently drastically different. I am going to double check stuff in a second. This can still do this. Steps, sure, needs to be out here. Yeah, steps need to be out here. Okay, so yes, the first example is AA, and the second example is 11A and 22A. Okay, so that seems to work because that's what the example input is as well. Now we want to do the same thing as we did before with this. And especially this. What I'm gonna do else, there's no part 2, and I'm gonna do the same loop. Except that I'm gonna say define all arrived with a list or with a cur, return false by default. So while not all arrived, I want to do this whole thing. Now, instead of just saying current equals directions current I, what I need to do is for each of our currents. So for C in gcur, and I'm gonna say I'm gonna create an ngcur equals this ngcur, a new ghost current dot append, and then directions of C and I, and then at the end I want to say, hey, at the end I say ghost current equals new ghost current, and then I need to say steps plus equals 1. So the same stuff that we've done before, and actually just do our loop, finish our loop. That's really what we need to do. So this whole looping part is the same. The only complication is that we now need to do it through a whole array. And our checking if we should keep looping needs to be a time more nuanced, and that is see if I can do it somehow clever. Sum, and I want to make an array 0 if if C2 equals Z for C in cur. Else 1, yeah. And then I can say I'm hoping for 0. I don't know if that's actually efficient, but the reason why I'm doing it this way is because I'm actually actively trying to practice. I'm actively trying to practice list comprehension. And that was right now a quick way for me to do this. So the idea here is this. I'm very sorry for that. Our dog is deaf. I don't know if you knew, but our dog is deaf. Sometimes she gets dreams, and she is scared that it's happening in real life. I wonder if she can hear in dreams that she cannot in real life. So she wakes up in dreams and just starts barking. And then she's looking around like, what's going on? Checking the surroundings. Yeah, she's on the couch right now. The idea here is this. I go through all of our currents, I say 4C in ghost currents. That is our current. And I'm checking this. I'm giving out a 0 if the last thing is a Z. So if we arrived. Otherwise, we give a 1. We sum it. And we hope that if any of them is not at Z, then we have at least 1, which means it does not sum to 0, which means we need to keep going. If all of them are at Z, it will return to 0 because the sum of all zeros is 0. And then we have arrived and it stops. That is my hope right now. And it's taking. It's taking. It's exactly what I was afraid of. Okay. The example was correct. I'm trying to already think of improvements. Is caching somehow possible? Is caching somehow possible? Or are they walking in some? Are they all walking in loops and we're just waiting for that one moment that they all line up perfect? Or do we need to come from 2 ways at the same time? It's still processing. It's not having an answer. I definitely need to think about optimization. I'm telling you, I have the feeling that this challenge is now going to have a massive drop in success rate for the second part. A part of me wants to debug it a bit more. Another part of me wants to just see if it comes up with it soon. If it's coming up with it soon. Which will be sweet. Input length 800. Many characters? 271 instructions. So our face is 271. So for 2 ghosts to walk the exact same path, they need to enter the same node at the same phase of 271. Which means at any other phase, they will take completely different paths. And even if I know through that's gonna still be so much saving and processing, just saving every single path that they take. The question still is, like, how do we know at one point they are going to go and meet each other? I'm interested in how many A's there are, how many Z's there are. I bet they're exactly the same. There's no gap. Wait. I'm having them. I'm very sorry of it for the quiet. I'm actually thinking this through. I'm wondering right now if it is faster just to compute a full graph of all the possibilities. Especially, we have already seen, okay, we're thinking about optimizations, okay? We have a lot of these where it actually leads to the same path. So I am wondering, how often does this happen? If this is the case a lot, what I can say is whenever it leads here, really two, like I can add for 2 steps, it leads to a different thing. So if I don't know, something else goes to TDK, how often does it happen? Only a few times. So here, HMR, if we go to TDK, what does it mean? Or QKB goes to TDK. That means that really we're sure to go to GHM afterwards. Which is sure to go to HPH. Which is sure to go to DRR. And then it splits up. So you see we're taking some decisions out of the tree. And I wonder if this happens a lot. So optimization number 1, and I'm letting this run while we think this through. Optimization number 1 is shortening the paths. Okay. And the way that we do that is if L and R are the same, what we want to do is we just direct, like, we can just replace that original instruction with that with the target, okay? Except if it's at the very end of that. Now, I don't know how much this does. I don't know how much this shortens it. The second thought is already go, like, what if I pre-compute a graph and I'm filtering out, yes, I'm filtering out dead ends. Filter out dead ends, if that's even possible. I don't know if that's possible. Because that would mean that there's a chance that some ghosts actually are stuck. And if that's the case, then I don't think that's possible. So I don't think this is possible. So I'm gonna keep this part off. But the graph could be interesting because then we can already see how to get to Z potentially. I'm thinking I'm just going through options right now. Until you find a good solution, you really just want to go through options. Another thing, I don't know if that's gonna help with disjoint sets. The idea with disjoint sets is to find loops. It's not gonna be helpful because we know there must be loops. It's so long there must be loops. We just what we're interested is when do they line up. Which, by the way, disjoint sets is one way to find loops. Another way is a double speed pointer system, where when you have a list, and then eventually this list does a loop, you have one pointer and another pointer, and one of the pointers doubles the speed of the other pointer. So first pointer goes here, the other one is here. Then the first pointer will be here, and then the last one here. Then this one will be here. This one came around and hits here. If they hit each other again, there's a loop. That's, by the way, another way. But we know, I'm pretty certain there is a loop, because otherwise it wouldn't take so long. We would have exhausted all the possibilities already. So there must be loops. The reason why I keep thinking is because even though this is right now the best idea is to shorten the paths, I don't know if it is the best idea. Also, this one, the implications are that we cannot go step by step anymore. That certain times now we need to move the whole thing forward by at least 2. So we need to keep track now, not just, hey, left and right, but also how many steps does it take? And how many steps do every other thing need to take as well? In my head, this all just gets more and more complex. The more I try to think about optimizations, the more complex it's all getting. Because I'm like, okay, now look ahead 2 or 3 times, 2 or 3 fields, and depending on the phase, tell me which one it is. But then I need to keep track of many different phases and many different locations that could end up in those 2 or 3 steps. And as more steps we go ahead, the more branched out it is. Is any of them Zs? Is none of them Zs? This is tough. This is actually tough. And like I said, I'm not an expert programmer, I'm an average programmer. So, like, I have no idea how to optimize this. Wait, jumping from Z to Z. I'm coming off of this graph idea here. Okay. And we have a Z right here, and then we jump, and we jump, and we jump, and we jump. And obviously we can jump in other directions as well. Eventually we hit other Zs. I don't care about any of these other locations. But I do care, hey, when do I reach the next Z? So here it would be 1, 2, 3 if I'm in phase 3. Let's say I'm in phase 7, I'm going to reach in 3. If I'm in phase 16, I'm going to reach it 1, 2, 3, 4, and so on. And we do. That does not seem incredibly complex, because we only have 270 odd phases. 271. I only expect that to be about 20-ish. That's what I'm hoping. I'm gonna double check that in a second. There's about 20-ish Zs, I'm hoping. If it's more 50, it's not gonna be 800. By the rough look of it, it's not even a tenth. So, if from each Z location and A location, because that's where we're starting, if from each A location and Z location I can save 271 locations of how many steps it takes to get to the next Z, then this becomes a pure mathematical problem. So I'm having a list of Zs. Okay, 1, 2, 3, 4, 5, 6. These are all Zs. And each of those gonna say now, hey, if you're in phase 1, it kind of takes 3 steps. If you're in phase 2, it's gonna take 7 steps. If you're in phase 3, it takes 15 steps. Phase 4 takes only 1 step, and so on. And we do that for each of them. Sure, this is complex, right? This is about, like, if this is 20 and then 271, this is about 1,000 different instructions. Sorry, more like 4,000. 4,000, but that is still a manageable amount. Even if this is 5 times more, then it is 10,000 instructions. It's getting large, but as far as we can see right now, it is massive, doing it step by step. So, 3 steps, and then also which that new location would be. And then I can just step around from here. From here, it jumps to here, it jumps to here, and then I can just compare. Hey, are the phases ever gonna start aligning up? And if not, I can do a whole bunch of shortening. This right now is the most promising appeal to me. Okay. Okay. If you're still here and you have been thinking with me and trying to figure this out, or maybe you've been shouting at me, David, hey, do this. Like, why are you not thinking about this? Why are you not thinking about this? Because I'm a knucklehead, okay? If you're still here, invested in me trying to figure this out, because I'm invested to figure this out, thank you. Don't give up on me. I want to see if this works. I hope it does. If there is a better solution and you have a better solution, please tell me in the comments. Right now, go down in the comments and let me know. I'm going to try to solve this right now. I'm going to try to solve it with this method. This is also going to include the path shortening. This is essentially path shortening and the graph combined. Especially since the left and right are then all gonna be vanished. We are not caring about individual instructions anymore. We are just caring about jumping from Z to Z to Z to Z. I hope this makes sense, and I hope we can find a solution this way. Let's go. Let's do this right now. It still doesn't have a solution. It still doesn't. I'm going to write now a second solve. Def solve 2 with D. Okay, and I'm going to start writing stuff in it. I want the instructions still. I want all of this. I want all of this stuff to still happen. Okay, all of this stuff I still want to happen. I now want to, though, create a Z map. Okay. I'm gonna call this a Z map. I like that actually. And I'm going through every single Z that exists. And then I'm also going through every single face that it could be at and calculate where the next Z is and which one it is at. So the distance and which one. That's the two things I need. And then we're gonna look again. And then we're gonna see what's happening. So for direction, for D in directions, if D technically I also need to do that for the ace, but I'm gonna think about the ace in a second. If D2 equals Z, then I want to do all the calculations now. Okay, so I can just do a list, face list. Okay, at the very end, after I have done my if, I want to say Z map of D equals face list. Yes. So now, how do I do this? I say count equals 0. And I need to say for I in range, it's length of instructions. So I'm gonna go through each of the instruction starting range. Am I right now creating an m times n squared algorithm? I think I am. So there's still more optimizations to be done. But I'm hoping that because this is way smaller, this is gonna go way faster. Because I feel like up here we're in an exponential form. Problems. You don't need to worry about this, yes. No, not Python console. Run. It's still doing it in the background. Maybe the question is what happens first? Is it gonna find it, or am I gonna have a new solution to run through? So for D in directions, face list, and then if it's Z, then I actually care about it. Actually like this. So now I'm going to go through all of the possible phases, starting with 0. And then I want to say what. Let me temp instruction equals instruction of I and until the end plus instructions from the beginning to I. This should rearrange. I cannot test any of this right now, which is annoying, but I will test it later. But this should, if it is correct, should split it in half and put the end part of the beginning and the end part of the front, the beginning part to the end. And then I can do the same thing as I'm doing up here. With this. And those paths should be shorter because we're not doing A to Z. It's just something A, something Z to something Z. So that should be faster. I lost my thoughts for a second. That happens sometimes. Yeah. So while, oh, that is not like this. Okay. So current equals D. If while actual I need to do it first and then do a while. Because we're already at Z. We already know that we're at Z. But I don't think Python has a do while. Python. Yeah. Python does not have a do while. Yeah. So I could do that. While true. And then I say if cur 2 equals Z. Yep, that works. Then I want to say break. Or I think inline it would be that this. Break if. No. Okay, fine. Do it the proper way. Okay, so for true, but then this is my exit clause. So s equals 0, that's my current step. If, no. Temp ins 2 equals this. So I say temp ins dot pop left. So that's T. Can use T still. And then I just do the same thing as I've done up here. Just need to adapt it. Okay. S plus equals 1. Temp ins 2. Dot append T. Temp ins 2. Okay. And then we check if current 2 equals Z, then break. Now we have for this face, we have the count. Which needs to be right here. I did it with S. We have the count and we have the final location, which is current. So we're just gonna say face list dot append a tuple with the count and the current. And this should make my Z map. This should make my Z map. Let's check it out. It still hasn't found it. So I'm actually breaking it now. Stopping it. I did it. If it was very close, I will never know. But it hasn't found it so far. It could have taken all day, by all I know. Don't do it again. Okay. No. Solve 2. And for map, I want to say solve 2. Honestly, this can be S. It's just for the test. No, I still want to do solve 2. No. No. Oh, I need to also return something. Return 0. Are we? We're not even getting. Please tell me we're not even getting to make our Z map. Are we on an infinite loop? Please tell me we're adding things to the face list. Print S and cur. Please tell me we're. Oh, infinite loops. There might be loops that don't actually include anything. So scene if cur in scene, then s equals -1 and break. And then I'm gonna say scene dot add. What? It's a set. I want this to be a set, please. Yes, add current. -1 xxx. Now I don't want to if. Yeah, that's fine. So from this Z, we can only go to one other Z, to itself. Okay, so this is actually interesting because this one goes to itself. And then this one is never reached. So essentially it goes to itself every 2 steps. Is that what I'm hearing right? It must. It must be. Must start at a stage where it reaches to itself. Does the code actually? Yeah. For 2z, we reach 2z actually always in 3. Apparently it's 2 different paths, but always in 3. So I could already tell now the shortest thing is 6 here. If they only reach themselves, that would make it the life really easy. If that is an observation that I can make right now for the big one as well, that they ever only reach themselves, stuff will be way easier. If they reach each other in crisscross ways, it's still the more complicated way. But if they only have loops with themselves, that is way easier. And I hope that is the case. So I also want to say face list. Yeah, I can't actually make sure that I can't combine these two, because this one, hey, it reaches this one in 3 steps if we start at phase 0, and it reaches this one in 3 steps if we start at phase 1. Here, if we start at phase 1, we will never reach another Z. That is the thing to think about. We always will. No, that's also not correct. I also want to say we will always start from phase 0, but no, we're starting at phase 0 at A. Okay. I am curious. I'm gonna just say 6 really quickly, so I can get. This is where I like to use PP. Pretty print. pp.pprints. There we go. So you see already, creating this is way easier, and you see how many paths there are that don't actually do anything. Oh, simplifying this will be very sweet. I'm so happy that I started this path this way. Okay, the face list will now be changed to a face dictionary? Face map. Okay. Now, face map, I only want to append, or face map, I only want to say it should equal that if of I if S is not -1. I don't know about you, but this seems way more doable. This seems like we can actually find a solution, especially because it loops on itself. I am so happy that I have been investigating this route. I could almost actually do it mathematically. I need to know when is the next time reaching an A from an A as well. So I'm gonna do that really quickly. I'm gonna really quickly do the same for A. A map. Okay, face map. Now, or D2 equals A. then I want to say if d2 equals z, I want to put it into the z map. Otherwise, I want to put it into the a map. In both cases, it's still looking for when the next z is happening. Oh, pprint is not happy with that. AAA reaches ZZZ. CFA reaches BQZ after 61 steps, starting at 210. Oh, that's not good. Those should start always 0. This is worrisome. It should be all starting at 0. Phase 0. Because that's where we're starting. If the only time it reaches as Z is if we're at phase 192, 210, 200, 198, 218, 212, then this is not possible. So we need to be finding something for phase 0. Oh, this is bad. I made a mistake. I made a mistake. I don't care if it's just current in scene, but S and current. Face is just as important. Oh no. Oh, S should be modulo length of instruction. Don't. Oh. Okay. Okay. That means it's finding something. Why is it? Oh. Okay, I need to still make sure that S. Yes, it can take multiple rotations. No, okay, okay. In the phase map, I want to do the actual steps, but here I want the phases. Okay. This is now a tiny bit more hurting, because it clearly seems like there's way more to it than it looked like earlier. But it's okay. So okay. It still seems like, I just want to put that out there, that these are self-sufficient loops. But we're getting more holistic maps here. So ZZZ, if we are at ZZ at phase 0, then it will take us to 409 steps to reach ZZZ again. That's why it took so long. If we had phase 1, we will already reach it in 1896. Phase 2 will take us 3792, and so on. That's the same with all the others as well. This is the exact type of map that I was hoping for. And the same with the ace. Yeah. For the ace, I only need phase 0. That is the interesting thing. So phase map, I only care about 0. So I'm glad that I fixed this. So this helps us with figuring out the modulo of the length of insert. What this does is it figures out the modulo is the rest, right? If you divide, you get the rest. And what you can get is you can essentially get a phase. So if you say divide a number by 3, and you count that number up, you get 0, 1, 2, 0, 1, 2, 0, 1, 2. That is the remainder. Because 0 divided by 3 is 0. 1 divided by 3 is 1. 2 divided by 3 is 2. 3 divided by 3 is 0. Or the modulos of those are 0 because the remainder is 0. 4 divided by 3 is 1 remainder 1. And so on. And that way we can phase through. So if we do remainder of whatever the length is, we can phase through that. Now, I want to cut off the A map, the phase map, if I is greater than 0 and D2 equals A, then I want to say, hey, now I have got enough. Okay. So the majority of this should just be, okay. Okay. So we can calculate how many steps it's going to take us to be at each of those Z locations. We literally just need to be, we now need to say, hey, that's the step that we are at after each Z location. Now we need to think about an algorithm that goes through those. The beautiful thing is I can always say modulo, and then we look it up, and then we say, hey, now you're here, take that new address. Now, the thing is, some of these might go faster than others. So what I want to do is I want to simultaneously keep track of the smallest and the largest steps. And I only want to update the smallest, update it, and then I take the next smallest, and then I update the largest as it goes. Eventually, the smallest and the largest will be the same number, and that is when we have the solution. I think we are getting there. We are getting there. We are now massively, massively shortening the amount of actually processing steps that we need to do because we have already calculated the massive amount of steps each of those take. But we needed these 14,000 steps. We need to do every single time we reach this part. Now we only need to once calculate plus 14,457. I'm actually also worried about big numbers, not gonna lie. Okay, I just need to reset myself. I would have that terminal would have never found a solution. I'm just saying. Okay. I need to think through. Ghost Currents is a dictionary. Okay. And I want to say for A in A map. Okay, so print A. The annoying thing, this is all gonna take now a little bit longer. I need to redo this every single time, but it's okay. Yes, I'm only getting one of the things. A and then A map A. I'm actually gonna stop returning the right thing. I'm now only gonna go on the small thing here. Okay. I want to really the A map. I'm only saying 0 equals, right? So A map D is face map, but really face map 0. Sorry, this still needs to be the dictionary. It's inside where we, yes, perfect. Okay, so this is our value, and this is where we reach to. Okay, so for A and A map, these are our two things. This is where we're starting from. I don't care about it. What I do care about is this part. I want to say G cur, and I don't actually care. I want to index by the current step. No, I don't. I can't because there might be multiple at the same step. That is the whole point, that eventually all of them will be at the same step. Fiddlesticks. Okay, so I'm gonna say this 1 equals this. Even that might not work if I think I couldn't check every single input. I think this is frustrating. So really A map is just is just our ghost current. That's really what AMAP is. Yeah. Rename AMAP to a ghost current. Yeah, yeah. Okay. Now, what I need to do is I need to check what my while loop is going again. While, and essentially, these are the addresses where they originally started from. They're not going to change. But these values are constantly going to change. What I'm going to say here is I have this, and I have the step that I'm at. And the cool thing is through the lookup, I can now say, hey, the step is actually at phase so-and-so. Now look up what the next one would be. Now, which I only want to do one of them at a time. No, all except the largest. If any of them are smaller than the largest, they need to do it eventually. So I can do all except the largest at a time. I can just do all the smallest one. It doesn't matter. I'm either looping inside or I'm looping on the while loop. So that's fine. So while not in sync, and that's my gcur pass. I'm gonna say def not in sync with my states. Return false. And this is really bad practice. While not in sync, this is the better practice. So if they're in sync, they're all the same. So I'm gonna go in sync equals true for s in states. First equals none. If first equals is none, well, first is none, then I want to say s t plus states s, and if s0, first equals s0, otherwise if elif first not equal s0, then in sync return false, and that's it. So what's happening here? We have a first variable. We go through all of the different states. We actually need to define the state because it's only going to give us the dictionary key. So then we're going to say, hey, if first is none, cool. Then just give me, then add first, and just do the first steps thing, and then go around. This will never reach then again. So then that means we're always going to check for this now. If first is not the same as the new value, that means they're not in sync, and we return false. Every time this is not the case, so that they are the same, it's not returning false, it's not returning false, and so on, until eventually it breaks and returning true. And that's how we know if they're in sync or not. So while they're not in sync, we do the process. We take the smallest one, We take the smallest one out of them. Smallest. Find. How do I do dictionary find by predicate? I might have asked it multiple times already. Dictionary find by predicate. Any. Next. Okay. Okay. So, what I want to say next, something. I'm making a list and say none. Well, I guess tuple. 4D or for C in G cur. I want to say. Oh, sorry. No. The reason I'm very sorry that I'm taking a moment. I'm trying to figure out how I can make it faster, make it work together. I really want to solve this. And I really want to solve it tonight. Tomorrow, by the way, I will upload a shortened version. I already made my mind up where I'm gonna just talk through the code once I know the solution. So smallest. Okay, smallest is just none. I just do it the way that I know. For C in G cur, GC equals G cur C. Well, I guess I could say I. And I can say C here. That makes sense. Now, what I want to say is I want to know I'm gonna save. Oh, come on. How am I saving it? How am I saving it? If smallest is none, then smallest equals I. I'm gonna save it by this. Else, elif, actually, if it's either none or smallest, G cur smallest G cur of smallest of 0 is bigger than G cur than C of 0. then smallest is I. Okay, yes. So what I'm doing is the zeros here are this first value, that's the actual step. And I want the one that has the smallest amount of steps. Okay? So if smallest is none, then smallest is I. I is just the index. Okay, I'm very sorry if you hear my dog snoring in the back. She snores like a human. We have weird dogs. Yes, so I is the index. Now, if we smallest is none, then we just take the first index. Otherwise, we look at the second part here. What we're doing is we're looking at the whole thing, indexing by the index, look at 0. If that is bigger than our new, which is G-chairs, and then our new index, and then 0, if that is, if this old one is bigger than that, that means we have found a new smallest one, and then we insert I as the new smallest one. Okay, so now we have the smallest. We have the smallest. Print smallest. And then, just so that we don't have an infinite loop, I'm gonna break. Yay, this is the smallest, and it's absolutely correct. Now, what we do with the smallest, we replace it. Okay, so we want to look up the new value. We want to look up the new value by the face. So we now want to look at ZMap. So gcur of smallest equals ZMap. I do want to remember what exactly is in there. Boom. ZMap of gcur smallest. I should really just save both, shouldn't I? Gcur of the smallest, and then 1, that's the address. That's the address that we're looking from. Then we are looking for the best face. So we do the current face. This is gcur smallest, and then 0 modulo length of ints. And then we're getting this, which would then be a new one. The only thing is that I want to add our current step to it. Okay. C step equals also, this is ridiculous. SV is for smallest value equals gcur of smallest. Boom. Now I can just say here smallest value, here I can say smallest value. Okay, and I already see that I have missed stuff here. Oh no. Yes, I have. Yeah, so that map here of S smallest value 1. So our smallest value is 1 is then the step. Is then the index. And then SV of 0 is the step, but divided by the moduled by the insert length. That gives us a new address here. Now I also want to make sure that I have the current step, which is from gcur, smallest value. So the smallest value of 1 is our current step. So what I now want to do is I want to say gcur smallest 0 plus equals sv 0. Print gcur. It should break if gcur is not gcur is now fully in sync. Tuple does not support item assignments. New value and new value 0 plus sv 0 and new value 1. Make this a tuple. There you go. This is taking forever still. Print gcur. I am curious to see what's happening. This should not be happening. They should have found it at 6. They should have found it at 6. They should have found it at 6. So 2 and 3, they will definitely not be the same. 1. Wait. What? Whoa. Okay, ST is this. Oh. Okay. This looks good. Now, since we broke, that means any of them will return a solution. So I just want to take any of them. No, how do I just address any of them? Return gcur. Can I just wait? Can I just keep the value? Overall step equals 0. And I can just keep track of whatever, because eventually they should be the same. Overall step equals SV 0, but not like that. Ooh. There. I'm scared because I'm I need to stop printing. Let's try again. Let's try again. Okay, first step done. Come on, please. After an hour and 45 minutes. Something. Please, something. If this isn't it, this is the way that I can most I understand most to comprehend to make it smaller. To reduce the amount of steps it needs to calculate. That is the most amount of steps I know how to that I could reduce it possibly. At least that I know. While it's doing this, I am very curious. Just leaderboard, day 8. Because they did it after 10 minutes. No, he didn't. Okay, sorry. He did the second one after. They did it after 10 minutes. They got the second solution after 10 minutes. No way. This makes me so sad. Just it doesn't. 4,918. I was a bit of a slow talker. Still calculating. If this isn't it, I'm gonna close the video for now. And I will finish it tomorrow. But I do want an entry in the rank sooner rather than later. You know my issue? I'm working with Python. This is like a thing you want to solve in C. Or Rust. Or assembly. Anything. But a high level language. For those that solve in JavaScript, gonna have a similar issue, if not worse. You must hear our dog like snoring so badly. I mean, it's all running software. I think this is it. This is it for today. I really thought this is a good way of just coming to an answer. Because I'm just cutting down thousands of steps at a time. Sometimes only 553. Sometimes 20,000. Sometimes 18,000. Many times about 10,000, 13,000, 79 once. An average about 10,000 steps. I'm doing in one step. That is really sad right now. This is really sad. I had really high hopes for this solution. At least I can say I gave it my best try. Like this whole thing of like actually making my maps here so that this goes faster, and then running, instead of running step by step, I'm running through the map. There's loops. Even here, we're reaching the same phase at this, like the same thing at the same phase over and over again. And if we have loops that are predictable, we find we really just multiply the current step by one another. It doesn't guarantee it's the smallest one, but it is a guaranteed one. It's like 2 and 3, right? The smallest one is 6 because it's 2 times 3. So we reach 6 by 2, 2, 2. Oh, after 3 times, right? And we reach 6 by 3, 3 after 2 times. So, and if we have that now with, let's say, 2, 3, and 6, like, well, they're gonna reach 12 is the shortest. 6, 6. If we ignore 6 itself, obviously. And it is 3 times 4, and it's 2 times 6. And even 4s now you can reach in 3 times. But what you can also do with 2, 3, and 6, and you multiply them by one another, is 2 times 3 times 6 is 36. And that will also be an overlap of all of them. Yeah. This has been almost 2 hours and it's still processing. I might just not stop it and just see if I get a solution when I wake up, but I have work tomorrow later and I can't be too tired for that one. So yeah, I need to sleep. Day 8 has defeated me. Sadly. At least the initial. I'm gonna come to a solution. And I am gonna... And I don't know if I'm gonna come to a solution by myself. I'm gonna try tomorrow some more off camera. But... And I'm probably gonna see what other people did and learn from them. That is for sure. So I'll get a star because I'm gonna learn from other people and see what they did. I'm gonna try to implement, without just copy and paste, I'm gonna try to implement the idea in my code. And then I'm gonna share with you what I have. I'm sad. It's defeated me. I actually thought I had something. Well, it was Advent of Code Day 8. A real hard one. I hope you enjoyed me struggle through this. And I see you tomorrow. Auf Wiedersehen.